In the beginning, there was not silence, but something far more profound. A stillness so complete it became a kind of music. Across the endless dark, before stars were born, before time had learned to count itself, the universe waited, not empty, but listening. To the human mind, space once seemed a void, a mute stage upon which matter performed its restless play. Yet modern physics whispers a deeper truth, that the very fabric of space-time breathes, trembles and sings in registers too vast for ears, too ancient for sound. Every atom's fall through gravity, every photon's curve around a star, every merging of black holes sends ripples through this invisible sea, faint shivers in the geometry of existence. These ripples are the hymns of reality itself, carried on a medium woven from time and distance. In this cathedral of silence, there are no walls, no boundaries, no center. Yet within it lies the architecture of everything, the spiraling arms of galaxies, the quiet pulse of quantum fields, the faint hum of gravitational waves crossing eternity. Each vibration is a note, each curvature a chord, all resonating in perfect, unknowable harmony. And so the ancient question deepens. If the void is not silent, if even nothingness hums with hidden life, then what does it mean to exist within its song? Perhaps the universe is not a static monument of matter, but a living symphony, one that has been playing since time's first breath, its echoes folded into the dark fabric around us. And perhaps, only now, with instruments tuned to the trembling of space-time itself, humanity is beginning to hear the first faint verses of the hushed choir of the universe. There are moments in history when the universe itself seems to lean closer, revealing something it has kept hidden since the dawn of time. One such moment arrived on a quiet morning in September 2015, when two mirrors, suspended in the stillness of an observatory in Louisiana, began to tremble. It was not the wind, it was not the hum of the earth. It was a ripple, faint, almost imperceptible, traveling across the very structure of existence. This was the first whisper from space-time itself. Billions of years earlier, long before the Earth had cooled, two black holes had circled each other in a deathly waltz. They had been born from dying stars, titans of hydrogen and helium that had burned through their lives and collapsed into singularities. Now, as they spiraled inward, their orbits decayed, their immense gravity twisting and deforming the fabric around them. The final moments were violent beyond comprehension. Two voids colliding, merging into one, releasing a flood of energy that rippled outward at the speed of light. That flood traveled for 1.3 billion years, untouched, unseen. It crossed galaxies, interstellar dust, the frozen darkness between clusters of stars. It passed silently through countless worlds and nebulae, through the arms of spiral galaxies and the yawning voids that separate them, until, one morning on Earth, it brushed against two observatories, one in Livingston, Louisiana, the other in Hanford, Washington, and set them trembling ever so slightly. The tremor lasted just a fraction of a second, but in that instant, humanity heard the universe speak for the first time. The Laser Interferometer, Gravitational Wave Observatory, LIGO, was a temple built to listen for what had never been heard. Each of its two detectors stretched 4 kilometers in length, their tunnels forming perfect right angles, lined with vacuum and guarded against every possible vibration of the Earth. At their core, a single laser beam was split into two, sent racing down each arm, bouncing between mirrors polished to atomic perfection. When the beams returned and recombined, they created an interference pattern, a delicate signature that would shift only if space itself expanded or contracted. For decades, physicists had doubted such precision was possible. The changes LIGO sought were unimaginably small. Distortions in space-time 1,000 times smaller than a proton's width. It was like trying to detect a change in distance between Earth and the nearest star smaller than the width of a human hair. But then it happened. On September 14, 2015, at 0950 UTC, both detectors recorded the same signal. A faint oscillation that rose and fell. A waveform, sweeping upward in frequency and amplitude before fading into silence. It was the echo of two black holes merging. The universe had trembled, and for the first time, humans had the ears to listen. The discovery was not an accident. It was the culmination of a century of theory, a whisper first imagined in the mind of a single man, Albert Einstein. In 1916, Einstein had written down the equations that redefined gravity. Where Isaac Newton had seen it as a force acting between masses, Einstein saw something deeper, the geometry of being. He proposed that space and time were not separate, but woven together into a single four-dimensional fabric, one that could stretch, curve, and bend under the presence of mass and energy. Planets did not orbit the sun because they were pulled by invisible strings. They fell along the curved path sculpted by the sun's own gravity. But Einstein's mathematics went further still. They suggested that massive objects in motion, especially accelerating ones, could cause ripples in this space-time fabric, just as a stone dropped into water sends waves across its surface. These were gravitational waves, vibrations in the geometry of the cosmos, carrying energy outward in expanding rings. Einstein, however, was uneasy. The waves were so faint, their effects so subtle, that he doubted they could ever be detected. In his lifetime, they remained theoretical ghosts, shimmering just beyond the reach of observation. For nearly 100 years, they haunted physics. Beautiful, elusive, and silent. The silence ended that day. When the data from both LIGO detectors were overlaid, they formed the unmistakable chirp predicted by Einstein's equations, a rising tone as the black holes spiraled faster and faster, merging in a final crescendo. It was not sound in the ordinary sense. Space does not carry air, and therefore cannot carry vibration. But when translated into frequency, the waveform produced something eerily human. A brief, ascending note, as if the cosmos itself had sighed. This was the first direct detection of gravitational waves, proof that space-time could ripple, stretch, and sing. To scientists, it was a triumph of precision and patience. To philosophers, it was a revelation. Confirmation that the universe is not still, not inert, but alive with subtle motion. The fabric of existence was not silent after all. It was a vast ocean, and for the first time, humanity had dipped a finger into its surface and felt the pulse beneath. What LIGO detected was energy on a scale beyond imagination. In the final moments of their collision, the two black holes released more energy than the combined light of all the stars in the observable universe. Yet it arrived as a faint ripple, smaller than a single atom's width. This paradox, power beyond comprehension, delivered in silence, is the essence of gravitational waves. They do not blaze like supernovae or erupt like quasars. They whisper. They move through everything, through worlds and bodies and time itself, leaving no trace but the smallest tremor in geometry. It is perhaps fitting that their discovery was made not by sight, but by listening. For centuries, humanity has looked outward, through telescopes and spectrometers, chasing light across the cosmos. But the universe is not only seen, it is heard, and its deeper truths are not revealed in brightness, but in vibration. The scientists who built LIGO called the event GW150914, a simple code for the date of detection. But within that string of letters and numbers lay a story billions of years in the making. The two black holes that merged were each about 30 times the mass of the Sun. Their union formed a single, heavier black hole with a few solar masses worth of energy converted directly into gravitational waves. This was energy transformed from pure curvature, from the collapse and union of space-time itself. In their wake, the universe continued as before, indifferent, vast, unchanged. Yet for one brief instant, something extraordinary had passed through us. It did not alter the stars, nor the tides, nor the heartbeat of the planet, but it changed human understanding forever. The first whisper was followed by others. In the years that followed, LIGO and its European counterpart, Virgo, detected dozens more signals, mergers of black holes and neutron stars, each with its own distinct signature. Each event was a word, a syllable, in the growing language of gravitational astronomy. Together, they revealed that the universe is not quiet, but filled with constant motion. Black holes colliding, stars collapsing, galaxies merging. The choir had always been singing. We had simply never heard it. Yet beneath the celebration of discovery lay something deeper, an awareness of scale. The waves that passed through Earth that day had traveled for over 1 billion years without fading, untouched by distance or matter. They had crossed the cosmic web itself, moving through galaxy clusters and intergalactic voids, through radiation and cold, dark energy. Their endurance was not one of strength, but of nature. Gravitational waves are distortions of space-time itself. There is no medium to scatter them, no obstacle to slow them. They are not carried through the universe, They are the universe moving. It is difficult to imagine such purity, energy that does not dissipate, sound that never decays, a tremor that echoes for eternity. But this is what makes them sacred to science. They are the most faithful messengers of cosmic truth. The significance of that first detection extended far beyond the thrill of validation. It confirmed Einstein's general relativity to astonishing precision, showing that even in the most extreme conditions, where gravity is strong and space itself folds inward, his equations still hold. It opened a new window into the cosmos, one that does not rely on light. For the first time, astronomers could observe invisible events, the collisions of black holes, the death spirals of neutron stars, not by what they emit, but by how they disturb the structure of reality. The implications were profound. It meant the universe was not only visible, but audible, not metaphorically, but literally in terms of its physical vibrations. And if gravitational waves could be heard, perhaps others exist too. Deeper, stranger tremors woven into the quantum foam, ripples from the birth of the cosmos itself. In this new light, the universe appeared almost sacred, a cathedral of curvature, vast and resonant. The black holes that collided were not just remnants of dead stars. They were the cathedral's bells ringing across space-time. Each wave that reached Earth was a relic of a moment long past, a fossil of motion preserved not in rock, but in geometry. And within that geometry, something poetic emerges. The idea that everything that has ever happened, every motion, every collapse, every union of matter, has left a mark on space-time. Every event sends its ripples outward, fading but never truly gone, stored in the cosmic fabric like vibrations still echoing in the strings of an ancient instrument. In that sense, the first whisper of gravitational waves was more than a scientific triumph. It was a philosophical awakening, a reminder that reality is not fixed, not silent, not still. It bends, breathes, and remembers. What we call empty space is, in truth, the most dynamic entity imaginable, a living stage upon which time and energy dance in infinite patterns. When those faint ripples reached us in 2015, they carried the memory of violence and creation, of collapse and union, of the raw forces that shape existence. And as they passed through the earth, through oceans and mountains and human hearts, they continued on, forever traveling, forever whispering, their message unchanged. The universe is not a void. It is a song, vast, slow, and eternal, and for the first time, we have learned to listen. There was a time when space was thought to be nothing, a black emptiness between the stars, a still and silent backdrop upon which the universe performed its play. For centuries, humanity lived under this illusion of stillness. Planets turned, comets crossed the dark, and Newton's invisible hand, gravity, guided their paths. Newton's universe was mechanical, clean, reliable. An apple fell because an unseen force reached out from the earth and pulled it down. The moon orbited because the same force bound it in an invisible leash. It was a cosmos of predictable obedience, objects moving through emptiness, each according to laws that never changed. But then, in the early years of the 20th century, one man looked at the void and saw something else. Not emptiness, but a stage that could bend, ripple, and sing. Albert Einstein did not destroy Newton's universe. He revealed its deeper foundation. He proposed that space was not nothing, it was something, a texture, a living geometry. He called it spacetime. In Einstein's vision, time was no longer a constant rhythm ticking in the background. It was woven together with space itself, a single, continuous fabric. Every particle, every planet, every star existed not in space-time, but of it. Matter and geometry were inseparable, locked in an eternal conversation. Gravity in this new picture was not a force at all. It was the shape of existence. The sun does not pull the earth. It bends the space-time around it, sculpting a valley in the cosmic fabric. The earth simply follows the curve of that valley, falling endlessly around the sun, bound not by force, but by geometry. The planets dance not through emptiness, but along invisible contours shaped by light and mass. The cosmos, once a clockwork of motion, became a cathedral of curvature. To understand what Einstein had seen, one must imagine the fabric of reality not as air or ether, but as something more abstract, a web of relationships between space, time, and energy. Imagine laying a sheet of silk across an open frame. If a marble is placed at its center, the silk dips. Another marble, placed nearby, will roll toward it. Not because the first marble reaches out and pulls, but because the silk's shape has changed. This is the essence of general relativity. Mass tells spacetime how to curve, and curvature tells mass how to move. It is an equation not of forces, but of form, an elegant balance between energy and geometry. And within that geometry lies the story of everything that has ever existed. Einstein's equations, when written down, look deceptively small. A handful of symbols, balanced in perfect symmetry, Gman, V, 8pgt Memen, G, C4, but behind these marks is a universe transformed. On one side of the equation stands Gman, a mathematical object describing the curvature of spacetime itself. On the other stands Teen, the energy and momentum of all matter and radiation within it. Between them lies a bridge of equality. Geometry equals energy. Space and matter are no longer separate. They shape each other continuously. A planet curves the space around it. The curvature dictates how the planet moves. Stars bend light itself, causing starlight to travel not in straight lines, but along cosmic arcs. Even time bends under gravity. Clocks run slower near massive objects. Their seconds stretched thin by the weight of curvature. The deeper one goes into gravity's well, the slower time becomes, until, at the edge of a black hole, it stops altogether. For the first time, humanity saw that the universe was not a silent void, but a flexible architecture, a cosmic fabric capable of motion, vibration, and song. If spacetime could bend, could it not also move? If it could move, could it not ripple, like a surface stirred by unseen winds? Einstein thought so. His mathematics predicted that accelerating masses, two stars orbiting one another, for instance, should send faint undulations outward through the fabric of reality. These would be gravitational waves, ripples in the geometry of being itself. But Einstein hesitated. He believed the waves would be so small, so faint, that they could never be detected. The idea was almost philosophical, a thought experiment, a curiosity whispered between pages of theory, and yet, a century later, the ripples would be heard. But before the universe could be heard, it had to be seen anew. Einstein's relativity did not merely describe how gravity worked. It changed how the cosmos was imagined. Where Newton's world was ruled by static laws, Einstein's was alive with interplay. Space was not a void, it was an elastic continuum. Time was not absolute. It flowed differently depending on motion and mass. Light was not untouchable. It bent and curved like water around a stone. Even the star's light, when observed near massive bodies, arrived shifted. Its color reddened, its frequency changed. The universe itself bent the rules of perception. The cosmos became fluid. The fixed scaffolding of reality dissolved into something dynamic, a breathing entity that curved under its own contents. In this view, every object, from the smallest grain of dust to the largest galaxy, contributes to the grand architecture of space-time. Each is both sculptor and sculpture. Each warps the geometry around it, and is in turn guided by that same geometry. The universe became not a stage upon which matter acts, but an instrument upon which matter plays. A neutron star vibrates space-time like a drum. A black hole hums at frequencies beyond hearing. Even the quiet drift of Earth around the sun sends faint ripples through the cosmic web. A lullaby too soft for detection. It is a vision of reality, both mathematical and musical. A symphony composed not of sound, but of shape. When Einstein first presented this vision in 1915, it was met with skepticism. The equations were beautiful but abstract, the consequences too strange. Could space truly bend? Could time truly slow? It would take years before proof began to emerge. In 1919, a solar eclipse offered the first glimpse. As the moon slid across the sun, starlight passing near the solar limb was deflected, bent precisely by the amount Einstein had predicted. The universe itself had curved the path of light. Newspapers around the world declared it a revolution. Lights all askew in the heavens. For the first time, humanity had evidence that the geometry of space could be altered by mass. Einstein's canvas was real. The cosmos was curved. From that moment, a new kind of imagination entered physics. one that saw gravity not as command, but as conversation. Space was no longer passive, it responded. A black hole was not a void, but a region where space-time folded upon itself. A neutron star was not just dense matter, but an extreme curvature frozen into form. Even the expansion of the universe itself, discovered by Edwin Hubble a decade later, could be understood as space-time stretching under its own cosmic energy. Everywhere, the fabric was alive, and if it could stretch, curve, and fold, then perhaps it could sing. To imagine space-time as a cathedral is not mere poetry. It is geometry expressed in wonder. Each massive object is a column of gravity arching upward through time. Each orbiting planet traces a pattern of motion, like a choir's echo spiraling through vaulted air. And at the center, the equations hum in perfect balance. Energy and curvature entwined in symmetry so pure it feels divine. In this cathedral, matter is not an intruder, but an organist. Its presence draws the shape from silence, transforming void into vibration. When a star collapses, it does not vanish into emptiness. It carves a note so deep that space-time itself resonates. When two black holes merge, the cathedral shudders, and the note carries outward, traveling for billions of years before it can be heard. The music of gravity is slow, patient, eternal. And so Einstein's realization was not only scientific, it was spiritual in scope. He had uncovered a unity that blurred the boundaries between object and environment, between being and space. There was no longer something in nothing. There was only everything, woven together. Even the vacuum, once thought empty, proved restless. Quantum theory revealed that beneath the calm surface, tiny fluctuations churn, particles and antiparticles blinking into and out of existence, stirring the geometry with invisible motion. Space-time, it turned out, is never still. It hums faintly with the energy of its own uncertainty. Perhaps then, it was inevitable that one day we would hear its true voice, not through light, but through motion itself. When the LIGO detectors heard that first whisper in 2015, they did not merely confirm a prediction. They revealed a truth that Einstein had only glimpsed in mathematics. They heard the music of his canvas. What was once geometry became melody. What was once silent theory became the living vibration of space-time. The universe had always been singing, softly, slowly, endlessly. It only needed the right instrument to make its song known. Einstein's canvas was never meant to be static. It is a living manuscript, rewritten every moment by the movements of stars, the births of galaxies, the collisions of black holes. Its notes stretch across billions of light years, forming harmonies that no ear can hear but every atom obeys. And somewhere within those harmonies lies the quiet truth. That existence is not a thing, but a rhythm. That the universe is not built, it is performed. And that every orbit, every fall, every breath of matter is a verse in the great, unending song that began when space first learned to sing. Across the silent plains of Washington State and the rolling fields of Louisiana, two immense corridors of steel extend into the horizon, forming perfect right angles beneath the open sky. From above, they seem almost sacred in their symmetry, two arms of a cosmic tuning fork, waiting for the faintest touch of eternity to make them sing. This is LIGO, the Laser Interferometer Gravitational Wave Observatory, humanity's most delicate ear pressed against the trembling skin of space-time itself. For decades, physicists had dreamed of such a device, one that could hear the inaudible, sense the ripples of reality as they passed invisibly through the Earth. The idea was almost absurd in its ambition, to measure distortions in the universe so infinitesimal that even atoms seemed vast by comparison. Yet within these quiet chambers of laser light and mirrors, that dream became real. At its heart, LIGO is an experiment in patience and precision. A single laser is split in two, sent down each arm of the detector, reflected off distant mirrors, and recombined again. In perfect stillness, the beams meet in harmony, their waves cancelling one another out in a delicate equilibrium of light. But when a gravitational wave passes through the Earth, space-time itself stretches and contracts, changing the distance each beam must travel. The interference pattern shifts, breaking the perfect symmetry, revealing a whisper in the geometry of existence. The change is unimaginably small, a fraction of a proton's width over 4 kilometers of vacuum-sealed tunnel. Yet it is enough to translate the motion of colliding black holes into measurable signal, enough to turn cosmic violence into vibration, enough to give silence its first true voice. To make such precision possible, the instruments must be suspended in isolation, mirrors hanging by thin glass fibers, untouched by the tremors of wind, footsteps, or even the movement of the air. The vacuum within LIGO's arms is among the purest ever created on Earth, emptier than interplanetary space. Every photon, every molecule, every grain of dust must be banished, for in this cathedral of measurement, even the faintest echo would drown out the universe's quietest song. When the detectors first caught the passing tremor of a gravitational wave in 2015, they did not hear it in sound, but in light. A tiny shift in interference, a pattern in the laser's rhythm. Yet when scientists converted the data into audio frequencies, a faint chirp emerged. 2 black holes had collided more than 1 billion years ago, and the fabric of spacetime had carried their union across cosmic distance to Earth. What the detectors recorded was not just a number or a graph. It was the final heartbeat of a dying orbit, the sigh of a universe still reverberating from its own creation. From that moment onward, the cosmos was no longer silent. Humanity had built an instrument capable of listening to the invisible. Beyond LIGO, others have joined the choir. In the hills of Tuscany, the Virgo Observatory extends its own arms outward. 3 kilometers of tunnel filled with laser light, working in concert with its American counterpart. Together they allow scientists to triangulate the origin of these gravitational ripples, to point not only to what was heard, but where it came from. Each new detection refines the universe's map, an atlas not of stars and galaxies, but of motion itself. In Japan, the Cathedrals Observatory burrows deep beneath a mountain. Its tunnels, cut through ancient stone, shelter its mirrors from seismic noise, holding them in a stillness that only the Earth's heart can provide. Within its subterranean halls, temperature and vibration are controlled with near-religious precision. The entire system is cooled to cryogenic temperatures, allowing the mirrors to move freely, untroubled by thermal jitter. Because even the smallest atomic vibration could obscure a gravitational wave's passage. And soon, the quest will rise beyond Earth. The LISA mission, the Laser Interferometer Space Antenna, will unfurl across the void between planets. 3 spacecraft, linked by beams of laser light, will form a triangle millions of kilometers wide. Floating freely through the gravitational tides of the solar system, LISA will become an instrument of unearthly sensitivity, able to hear the universe's lowest notes, the slow, massive ripples born from supermassive black holes spiraling together in the hearts of galaxies. If LIGO and Virgo are the organ pipes of a cathedral rooted to the ground, LISA will be the choir suspended in heaven, drifting silently through the music of space-time. Each of these instruments extends the same idea, that silence itself is not empty, but structured, that the void carries memory, rhythm, and resonance. Through their laser light, humanity listens not to sound, but to distortion, to the bending of geometry itself. What they measure is not the passing of matter, but the shifting of the invisible grid that defines all motion, all shape, all distance. These machines transform abstraction into revelation. Einstein's equations, once bound to chalkboards and thought experiments, are made tangible through their beams. The curvature of spacetime, once a metaphor, now oscillates through sensors and circuitry. Each detection is a note plucked on the cosmic harp, proof that the universe's structure is not static, but alive with motion and vibration. To build such sensitivity, engineers had to confront the limits of material itself. Every mirror polished to atomic perfection, every laser stabilized to frequencies billions of times finer than a clock's tick, every suspension designed to float in stillness embodies the same pursuit, to remove human noise and leave only the music of the cosmos. And yet, even with this exquisite precision, the signal is fragile. A passing truck miles away, a wave crashing on a distant shore, or even the shift of tides beneath the Earth's crust can mimic the pulse of a gravitational wave. Scientists sift through oceans of noise, searching for patterns, for coherence across detectors, for the telltale rise and fall that signals something vast, ancient, and real. The process is as much art as science, an act of listening, of interpretation, of faith in the faint. For what they seek is not loud. The loudest collision of black holes ever recorded distorts spacetime by less than 1 part in 1,000 trillion. And yet in that infinitesimal trembling, the story of creation unfolds. These observatories are humanity's most advanced temples of silence, built not to generate power or wealth, but to listen, to understand, to reach. Their walls hold no worshippers, no statues, no gods, only mirrors, lasers, and the unending patience of those who believe the universe still has secrets worth hearing. And slowly, through them, the cosmos is revealing a hidden architecture, not made of stars and planets, but of rhythm and resonance. The waves detected are not isolated events. They are part of a grander pattern. Each detection adds a new note to the universal score, mapping where gravity sings most fiercely, where time bends most violently, where the deepest cathedrals of space-time still echo from their own creation. With each wave, physicists glimpse something older than galaxies, the fabric of reality itself, stretched and stirred by forces beyond comprehension. The collisions of black holes, the collapse of neutron stars, the merging of matter dense enough to warp time. All these are verses in the same ancient hymn. As Lisa prepares for launch, the scale of the listening expands. The soundscape of space-time will soon extend across millions of kilometers, far from Earth's interference. In this silence, the detectors will trace vibrations that have traveled for billions of years, waves so deep and low they move like the heartbeat of the universe itself. Some may even carry echoes from before the first stars, from the instant of cosmic inflation, when space-time itself first learned to sing. And so the journey continues, from mirrors on Earth to instruments among the stars, from trembling lasers to the very pulse of creation. These are not just tools of physics, but organs of perception, extensions of human awareness reaching into the dark. Through them, the universe ceases to be an object observed and becomes a presence felt, a living architecture whose quiet motions speak across time. What began as a whisper at LIGO has grown into a chorus of discovery, revealing that the fabric of existence is not still, not cold, not empty, but resonant, dynamic, and alive. Each new detection reaffirms a profound truth, that to understand the universe, one must first learn to listen. And as humanity refines its instruments, stretching light across continents and constellations, it may one day hear the faintest, oldest music of all, the tremor left from the first instant of being, when silence itself broke and the cathedral of space-time began to sing. The universe has never been silent. It has only been waiting for someone to listen. When the first gravitational waves reached Earth in 2015, they carried with them a story written not in light, but in motion. A message from the hidden hearts of 2 black holes that had collided over 1 billion years ago. Their meeting was neither gentle nor brief. In the final fraction of a second, they released more energy than all the stars in the observable universe combined. Yet this energy was invisible, not a flare or burst, but a ripple in the very shape of space. What arrived was not a flash, but a tremor, a brief perfect note in the great silence, a tone of pure curvature. It marked the birth of a new kind of astronomy. For centuries, humanity had looked to the sky with eyes of glass and mirrors of light. From Galileo's telescope to the Hubble Space Telescope, all of astronomy was bound to brightness. Every discovery came from what the universe allowed us to see. Stars, galaxies, nebulae, the luminous fraction of existence. But gravitational waves revealed a cosmos that does not need light to speak. In their trembling passage through space-time, the blind began to hear. This was the beginning of what scientists call multi-messenger astronomy, a fusion of sight and sound, of light and gravity. But the word sound is a metaphor, for in truth, what is heard are oscillations in space-time itself, the rise and fall of invisible tides washing across the cosmos. Each wave is born in violence. Black holes merge, neutron stars collide, entire regions of space-time fold and release like fabric caught in a storm. These are cataclysms of unimaginable scale. Yet when their echoes finally reach us, they are soft, smaller than an atom's width as they ripple through Earth. The contrast is almost spiritual. Cosmic annihilation translated into the gentlest shiver of measurement. As more detections followed, a new realization emerged. These waves were not isolated events, but part of a vast and ongoing symphony. Each merger added another verse to a choir that had been singing since the dawn of structure itself. In 2017, LIGO and Virgo together captured something extraordinary. Not the collision of black holes, but the union of two neutron stars. These remnants of massive suns, crushed so tightly that a teaspoon of their matter weighs billions of tons, spiraled inward in a fatal embrace. Their merger produced both gravitational waves and light, a rare and precious duet. Telescopes around the world saw the flash, while detectors felt the tremor. For the first time, the universe sang in harmony, a melody of gravity and brightness intertwined. This event, known as GW170817, revealed the origin of the heaviest elements: gold, platinum, and uranium, forged in the explosion's aftermath. Every ring on a human hand, every glint of metal in a star, might once have been part of a neutron star's death cry. Each atom born in those fires now drifts through living worlds, the residue of a cosmic hymn. As detections accumulated, patterns began to form. Black holes were not singular monsters, but members of a vast unseen population, binaries orbiting, merging, and echoing throughout the dark. Some were small, only a few times the mass of the sun. Others defied expectations. Giants 30, 50, even 80 times more massive, their collisions leaving behind black holes larger than any ever seen in starlight. Each event carried its own tone, a distinct signature in the gravitational spectrum. To a physicist, these are not mere curiosities, but syllables in a deeper language. They encode the geometry of the colliding masses, the distance between them, even the texture of the space-time they distort. From these notes, the universe's architects can be studied, their stories reconstructed. It is a kind of archaeology, not of bones or ruins, but of gravity itself. Each detection is a fossil of curvature, a record of where the universe folded and healed. In this way, scientists have begun to chart the invisible, the population of black holes too distant or dark for any telescope, the cosmic history of collapse and coalescence. Yet behind this precision lies poetry. Each wave that passes through Earth is not merely data, it is a memory, a fragment of the universe remembering itself. These ripples carry the record of collisions that ended before life on Earth began, vibrations that have traveled across expanding space for eons, untouched, unchanged. To detect them is to touch a past that still moves. In the great quiet, these echoes form what one physicist called the Black Choir, a chorus of gravitational songs emanating from every dark collision across the cosmos. It is not a metaphor, but an observable fact. Black holes hum. Their oscillations, known as ringdowns, occur in the final moment after merger, when the new, larger black hole settles into symmetry. Each ringdown is a resonant frequency of space-time itself, a soundless tone that can reveal the black hole's size, spin, and purity. These frequencies obey the mathematics of Einstein's field equations with exquisite accuracy. Yet they also test its limits. In the future, as detectors grow more sensitive, physicists hope to find imperfections in these tones, slight deviations from what general relativity predicts. Such deviations could signal something profound, the breakdown of Einstein's framework, or the presence of new physics, perhaps the first hint of quantum gravity. In this way, the Black Choir is both confirmation and question. It sings the truth of relativity and hints at what lies beyond. To imagine these events is to witness the universe composing itself. Each collision is a note played in gravity's grand symphony, short, violent, but eternal. Unlike light, which can be scattered, absorbed, or lost, gravitational waves pass through everything. They cannot be blocked or silenced. Even the densest star, the most distant galaxy, cannot hide from their touch. They travel uncorrupted, carrying their truth unblurred by the cosmos they cross. In the future, as detectors like LISA unfold in space, the choir will deepen. Humanity will hear the lower, slower songs, the merging of supermassive black holes, each millions of times the mass of the sun. Their ripples will move like the slow tolling of bells across the cosmic sea, stretching over hours or days. These will not be chirps, but droning hymns, the deepest bass of the universe's orchestra. And beneath even those, theorists suspect, lies a hum that never stops, a cosmic background of gravitational waves, born from the earliest instants after the Big Bang. These are the faintest echoes of creation itself, the residue of inflation when space-time expanded faster than light. To hear them would be to listen to the universe before it became visible, before there were stars, atoms, or even light. It is a goal that may take centuries, yet it represents something eternal in human curiosity. The desire to listen where sight fails, to find meaning in the motion of nothingness. For now, the Black Choir continues unseen, its members scattered across the abyss. Each black hole's song is brief, lasting only seconds, yet together they weave an endless continuum of resonance. They are the unending requiem of matter returning to simplicity, the geometry of space remembering its own fall into itself. In these moments, gravity is no longer a quiet force, but an artist. Its brushstrokes are waves, its canvas the fabric of reality, its art eternal and invisible. Every detection is a glimpse of this art, the curvature of space drawn by collapse, the whisper of time distorted into form. When Einstein first imagined space-time as a pliable fabric, he could not have known that one day humanity would listen to it sing. But that is what gravitational wave astronomy has become. Not just observation, but communion. Each wave that passes through Earth, though faint and fleeting, is part of something vast. An unending composition that began with the first collapse of the first star, and will continue until the last atom dissolves into darkness. It is said that in music, silence gives meaning to sound. In the universe, perhaps it is the reverse. That silence itself is sound stretched across eternity, a resonance too deep to hear. Through the instruments of light, we have seen the stars. Through the instruments of gravity, we have begun to hear the dark. And in that hearing, a new understanding begins to unfold, that the universe is not a void scattered with matter, but a living field of vibration, a cathedral whose every arch and column trembles with unseen harmony. The Black Choir sings still, its voices woven through the infinite fabric, each note a revelation, each echo a reminder that even in darkness, the cosmos does not sleep. It remembers, it moves, it sings. In the beginning of all motion, there must be something unmoving, a ground upon which the dance of creation can unfold. For every vibration, a silence that gives it shape. And as scientists began to listen to the music of the universe, the ripples of space-time itself, a deeper, more unsettling question began to take form beneath the triumph of discovery. If space-time can ripple, what holds it still enough to ripple upon? In laboratories bathed in artificial twilight, equations glow across digital screens like constellations mapped in code. Physicists stare into this symbolic cosmos, searching for the unseen substrate beneath all that moves. It is here, in the invisible space between particles, in the void itself, that modern physics begins to tremble. Einstein's equations describe space-time as a flexible fabric, bending under the weight of mass and energy. But quantum field theory paints another portrait, one where even emptiness seethes with unseen life. According to this view, the vacuum is not nothing. It is everything in disguise. Every inch of what appears to be empty space is, in truth, a restless ocean of quantum fields, flickering in and out of existence with unimaginable speed. Particles are not objects moving through space. They are excitations, waves rising briefly on this infinite sea. When the waves settle, the ocean appears calm again, but the calm is an illusion. In 1948, Dutch physicist Hendrik Casimir proposed an experiment to prove that the vacuum was not truly empty. He imagined two metal plates placed a fraction of a millimeter apart within a perfect vacuum. If the void were truly void, there should be no force between them. But if it seethed with invisible energy, the fluctuations would differ slightly inside and outside the gap, pushing the plates together with a measurable force. Years later, when the Casimir effect was confirmed, The results sent quiet shockwaves through the scientific world. Nothingness, it seemed, was capable of exerting pressure. The vacuum was alive, a breathing stillness, whispering in the language of quantum uncertainty. This was not a silence of absence, but of balance. An eternal cancelling out of infinite notes, a cosmic hum that could only be heard in its rare disruptions. Quantum field theory predicts that each point in space contains an energy density so vast that, if taken literally, the vacuum should collapse into itself. The numbers are absurd, exceeding the observed energy of the universe by more than 120 orders of magnitude. This discrepancy became known as the vacuum catastrophe, the most spectacular mismatch between theory and observation in the history of science. In one hand, mathematics describes a universe drowning in energy. In the other, observation reveals a tranquil cosmos, stable, expansive, enduring. Something, somewhere, is being misunderstood. To physicists, it is as if two realities exist at once, one screaming with infinite potential, the other serenely unfolding in time, and between them, a stillness no theory can yet touch. In recent decades, cosmologists have turned their attention to dark energy, the mysterious force causing the universe's expansion to accelerate. It behaves, in some ways, like vacuum energy, a constant pressure that pervades all of space, stretching it ever outward. Could it be that what we call dark energy is the faintest whisper of that quantum restlessness, the residue of infinite motion, diluted by time and cosmic scale? If so, then the silence of the cosmos is not absence, but restraint, a stillness vast enough to contain creation itself. This view reshapes the cathedral metaphor that began with LIGO's listening towers and their laser-lit corridors. Those observatories captured the tremors in spacetime, the music of merging black holes. But beneath that music lies the cathedral's foundation, the invisible floor of reality, trembling so softly it becomes indistinguishable from peace. To glimpse this paradox, scientists probe deeper into the structure of the quantum vacuum. Virtual particles, ghostly pairs of matter and antimatter, appear and vanish in less than a heartbeat. Their births and deaths occur everywhere, all the time, a silent storm of existence continually erased. In the emptiness surrounding an atom, these fleeting presences shift the energy levels of electrons. This subtle effect, the Lamb shift, was one of the first fingerprints of the vacuum's hidden hand. Even atoms, it seems, are never alone. They float in an unseen tide, rocked by waves of ephemeral creation. And yet, from this chaos comes precision. The rules of quantum mechanics, though bewildering, ensure that the fluctuations average out to near perfection, a stillness carved from infinite motion. Like the surface of a deep ocean, it looks calm from above, though every molecule churns in invisible dance. To disturb that calm is to touch the raw fabric of reality. Some theorists imagine that this quantum sea may be the true foundation of spacetime itself, that the geometry Einstein described arises as an emergent property, like waves forming patterns upon deeper waters. In this picture, gravity is not a fundamental force, but a resonance, a collective rhythm of countless microscopic fluctuations, all swaying in intricate harmony. If that is true, then spacetime is not the final layer of reality. It is a veil, woven from deep emotion, a shadow of something more primal, more silent. And perhaps, beneath even that, another stillness waits. The human mind struggles to conceive of such layered foundations. Every discovery seems to rest upon another question, like mirrors facing each other into infinity. But there is something profoundly human in this pursuit, this search for the still point at the heart of motion. In the vast laboratories of Geneva and Tokyo, in underground chambers and spaceborne detectors, the same yearning persists, to find what lies beneath, to know whether silence itself has a sound. Physicists study quantum fluctuations, yet in doing so, they also encounter a deeper philosophical unease. For if everything is motion, where does stillness come from? If the void is a storm, what then is calm? And if time and space are born from fluctuations, who, or what, is the observer of that birth? These questions drift between physics and metaphysics, between the measurable and the meaningful. The stillness beneath motion is not only a physical mystery, but a mirror held to consciousness itself. In the early universe, When the cosmos was less than a trillionth of a second old, quantum fluctuations rippled through the hot plasma that filled all of existence. Tiny variations in energy density were stretched by inflation, seeding the structure of galaxies and stars. The universe we see today, its vast web of light and shadow, was sculpted by whispers in that ancient vacuum. Creation, it seems, was born not from chaos, but from the stillness beneath it. Even now, as telescopes peer deeper into space and time, what they see is the frozen record of those primordial tremors. The cosmic microwave background, that faint afterglow of the Big Bang, is the lingering warmth of quantum fluctuations magnified to cosmic scale. In every direction, the universe hums with their memory, and so the paradox deepens. The stillness beneath motion is not a passive void, but a creative engine, one that never ceases, one that sustains existence by forever balancing on the edge of instability. When black holes collide, their gravitational song echoes through spacetime, passing through Earth as a shiver in geometry. But even those mighty events, those cataclysmic hymns of creation, are small compared to the orchestra of the vacuum itself. Between each detected wave lies a silence infinitely richer, a silence made of motion too subtle to name. The detectors of tomorrow, like the space-borne LISA observatory, will stretch their arms millions of kilometers wide, floating in the dark between planets. They will listen not only for the loudest notes, but for the quiet background hum, the gravitational murmurs that may reveal the early universe itself. And if they succeed, humanity will have heard the first true whisper of the stillness beneath all motion. Every advance in physics carries us closer to that horizon, the meeting point between knowledge and wonder. Each equation is a window cut into the unknown, each experiment a hand reaching through it. But the closer science comes to describing the foundation of reality, the more it begins to resemble poetry. The equations of quantum field theory, written across chalkboards, read like hymns to the invisible. They describe fields that have no edges, oscillations without particles, potential without substance. To the untrained eye, they are symbols. To those who listen closely, they are prayers for understanding. Perhaps this is the quiet truth behind all motion, that the universe is not something moving through space, but something becoming space itself, endlessly, delicately, invisibly. Each vibration, each gravitational wave, each flicker of a virtual particle is a verse in an eternal composition. And beneath it all, the silence persists, not as absence, but as foundation, a stillness vast enough to contain both chaos and order, both birth and decay. It is here, in this paradoxical calm, that the story of existence continues to unfold. A cosmos of ceaseless motion, built upon a stillness that can never truly be known. In the cathedral of the invisible, the instruments of gravity hum their patient notes. The mirrors of LIGO stand poised in quiet anticipation. The stars spin, black holes merge, galaxies drift apart. And somewhere, beneath it all, beneath motion, beneath sound, beneath the trembling of space-time, the universe holds its breath, waiting, perhaps, for us to learn how to listen. In the dark between atoms, in the silence between waves, there exists a trembling so faint it escapes all instruments, yet it never ceases. Even in perfect emptiness, the universe hums. This hum is not made of sound, nor light, nor motion as we know it. It is the subtle vibration of existence itself, a ceaseless fluctuation at the heart of what we call nothing. And from that trembling, everything arises. To understand the stillness beneath motion, physicists ventured inward, beyond atoms, beyond protons and neutrons, into the deepest recesses of the void. There, they discovered something astonishing. Emptiness is not empty. It is a sea of potential, alive with invisible music. In this invisible ocean, particles flicker in and out of being, fleeting, spectral presences born from uncertainty itself. They appear without warning, borrow energy from the vacuum, and vanish just as quickly, leaving behind only the faintest trace of their passage. This restless activity is called quantum fluctuation, the heartbeat of the void. It defies intuition. For centuries, nothingness was thought to be absence. But in the quantum world, absence itself becomes a presence, a dynamic, creative field that never truly rests. This is the quantum foam, the deep structure of the universe's foundation. an infinite chorus of ephemeral events occurring everywhere, all the time. Each fluctuation is a whisper in the great hymn of reality. The equations of quantum field theory describe this symphony with mathematical precision. Every fundamental force, every known particle, emerges from a corresponding field that fills all of space. The photon is not a wandering particle of light, but a ripple on the electromagnetic field. The electron is a localized vibration in its own field. Even gravity, though still elusive in the quantum realm, may be the softest tone in this cosmic choir. In this picture, the universe resembles a vast orchestra of invisible instruments, overlapping, resonating, interfering. Each field vibrates even when no note is being played. This background vibration, the zero-point energy, is the irreducible minimum of motion, the faint hum that remains even when all else falls silent. It is the universe's baseline, the cosmic drone upon which all other melodies are built. The story of this discovery begins in the middle of the 20th century when physicists struggled to reconcile classical emptiness with quantum mechanics. They found that even at absolute zero, the coldest possible state, where thermal motion stops, the energy of the vacuum does not vanish. It lingers quietly in the fabric of space itself. This zero-point energy gives rise to measurable effects. One of the most haunting is the Casimir effect. When two uncharged metal plates are placed extremely close together, just a few nanometers apart, they begin to attract, even though no external force acts upon them. The space between them excludes certain wavelengths of the vacuum's quantum fluctuations, creating a tiny pressure difference that pushes the plates together. The void, it seems, has weight. Even nothing has something to say. This subtle pull, first predicted by Hendrik Casimir in 1948, is a whisper of the quantum sea pressing its invisible hand against matter, a reminder that the vacuum is not a void, but a living, breathing ocean. The implications ripple outward, reaching from the smallest scales to the structure of the cosmos itself. If the vacuum is filled with this ever-present energy, what role does it play in shaping reality? Some theorists believe these fluctuations underpin the very stability of atoms, preventing the electron from collapsing into the nucleus by ensuring the universe never reaches perfect stillness. Others see in them the seeds of creation itself. During the universe's first fraction of a second, a field, possibly the Higgs or something yet unknown, may have fluctuated violently, triggering cosmic inflation. This inflation expanded the universe faster than light, ironing out its wrinkles, stretching quantum ripples into the vast galaxies and voids we see today. Every star, every planet, every breath of life may trace its lineage to a tremor in the quantum void. A fluctuation so small it could not be seen, yet so vast in consequence, it gave rise to everything that followed. To imagine this is to reimagine existence itself. The universe is not a static stage upon which events occur. It is an instrument continually tuning itself. Space and time are not containers, but melodies, the result of deeper harmonics resonating through the quantum sea. And like any instrument, the universe carries imperfections, dissonances, subtle beats between overlapping tones. These beats, these fluctuations are what give rise to form. Without them, there would be no motion, no gravity, no light, no difference, and thus no being. Quantum uncertainty lies at the heart of it all. It states that one cannot know both a particle's position and momentum with absolute precision. The more clearly one is known, the more the other dissolves into ambiguity. This uncertainty is not a flaw of measurement. It is the fabric of existence itself. The vacuum's fluctuations are a direct expression of this rule. If energy and time cannot both be precisely known, then energy may briefly appear from nowhere, provided it disappears quickly enough to satisfy the cosmic bookkeeping. Nature, it seems, tolerates short-lived miracles. These ephemeral bursts of energy are what fill the vacuum with its tremor, and though they vanish almost instantly, their collective effect is eternal. Some physicists suspect that what we call space-time might emerge from these fluctuations, that gravity and geometry themselves are products of deeper quantum entanglement. In this view, the smoothness of space is an illusion, like the surface of a lake that hides a churning chaos beneath. Each point in space, each quantum of energy, is entangled with every other. The universe is a network of relationships, not things. And within that network, the void is not the absence of being. it is the web itself. In recent theoretical work, from quantum gravity to string theory, the idea of the vacuum as a dynamic structure grows ever more profound. In string theory, for instance, the fundamental entities are not point particles, but tiny vibrating strings, each resonating at specific frequencies. The vibrations pattern determines whether it appears as matter, light, or gravity. Once again, the universe reveals itself as a musical composition, a cosmic choir whose voices are strings of energy, singing in dimensions beyond sight. And yet, for all our mathematical mastery, the true meaning of the quantum void remains beyond comprehension. Its energy is immense, so immense that if the theoretical value of vacuum energy were correct, the universe would collapse instantly under its weight. Yet it does not. It expands, slowly, gently, as if balanced between silence and song. This contradiction, known as the cosmological constant problem, is one of the deepest mysteries in modern physics. Einstein once introduced the cosmological constant to keep his equations static, believing the universe must be eternal and unchanging. Decades later, the discovery of the accelerating expansion showed that such a constant does exist, but its value is so small, so finely tuned, that it defies explanation. It is as if the universe walks a tightrope stretched between infinite possibilities, its balance maintained by a harmony no one yet understands. When observatories like LIGO detect the faintest ripple in spacetime, they are, in a sense, hearing a note within this greater symphony. Each gravitational wave is a distortion in the cosmic fabric. But the fabric itself, the stage upon which these waves travel, is already trembling with quantum life. The sensitivity of these instruments approaches a paradox of scale. They listen for distortions smaller than a proton, while floating within a sea of vacuum fluctuations that never rest. Yet the signals emerge, clear, distinct, as if the universe, despite its turbulence, allows coherence to rise from chaos. Perhaps that is its nature, a music that sustains both noise and order, both randomness and pattern. If the quantum void is a choir, then its song has no beginning and no end. It does not crescendo or fade. It simply is, a continuous resonance that underlies every act of creation and destruction. From the flicker of virtual particles to the birth of galaxies, from the decay of atoms to the pulse of time itself, all follow from the same trembling foundation. The stillness of space-time and the turbulence of the vacuum are two sides of the same truth. Stillness is not the absence of vibration. It is the perfect equilibrium of infinite vibrations. In that light, the universe no longer appears as a hierarchy, from atoms to stars, from galaxies to voids, but as a single vast resonance, self-sustaining and self-aware. Every field, every particle, every force is an overtone of the same fundamental tone. And beneath it all, the trembling void continues its eternal hymn, inaudible, invisible, yet omnipresent. It may be that one day, as technology advances, we will measure these fluctuations directly. We will observe the heartbeat of nothingness and confirm that even the quietest corner of the cosmos is alive with motion. But even then, a question will remain. What lies beneath that motion? What gives rise to the choir itself? The search for answers continues not only through physics, but through reflection, through an awareness that science and wonder are not rivals, but reflections of the same curiosity. In the cathedral of the cosmos, the quantum fields are the unseen organ pipes, vibrating across every atom, every star, every horizon. Their song is the architecture of existence, and the void, that trembling silence, is both the stage and the symphony. For in the end, the universe may not be a place of things at all, but a harmony between them, a quantum choir, singing forever in the trembling void. Before the first light, before matter, before even the concept of before, there was only silence, an unmeasurable stillness that held no form, no boundary, no time. Yet within that stillness something stirred, a breath without lungs, a motion without direction, a vibration that did not yet know what to vibrate. This was not sound, not even energy in the ordinary sense, but the first murmur of expansion, the awakening of space-time itself. The birth of the cosmos was not an explosion in space. It was space, unfolding, swelling, breathing into being. In that first instant, less than a trillionth of a second after the beginning, the universe expanded faster than light, not because anything traveled through space, but because space itself was being born. This moment is known as cosmic inflation, a flash of inconceivable growth that turned a quantum ripple into a universe. If one could see it, it would not look like fire, nor sound like thunder. It would be pure geometry in motion, a fabric stretching, curling, expanding in every direction at once, carrying with it the seeds of all future structure. Galaxies, stars, atoms, even time itself, were written into the rhythm of that first breath. In this inflationary era, space-time was soft and fluid. Tiny fluctuations, born from the quantum foam, were stretched across cosmic scales. Each ripple became a region of density, a future galaxy, a cluster of stars, a cosmic filament that would one day weave the great web of the universe. These were the first chords in the silent symphony of existence. Modern cosmology traces this origin through faint relics that still drift around us today. The cosmic microwave background, or CMB, it is the oldest light in the universe, released when the cosmos was only 380,000 years old. To human eyes, it is invisible. To radio telescopes, it glows with a near-perfect uniformity, a faint whisper of heat from when space was still young. Embedded within that glow are tiny variations, minute differences in temperature and density. They are the fingerprints of the universe's first breath. These variations are more than relics. They are echoes of primordial sound waves, compressions and rarefactions rippling through the early plasma of particles and light. Long before the first star, the young universe rang. It vibrated with acoustic oscillations, pressure waves moving through an ocean of charged particles and photons. The cosmos, in its infancy, was a vast resonant chamber, a cathedral of plasma humming with creation's first song. And just as in any cathedral, its architecture determined its harmonics. The size, the shape, the density of the early universe defined the frequencies that would later emerge as galaxies and voids, light and darkness, order and entropy. When modern telescopes like Planck and WMAP mapped this ancient glow, they revealed the structure of this primordial music, an orchestra frozen in time, still playing across the sky. Every pixel of that map tells a story of expansion, of balance, of a breath that has never stopped. Physicists believe that even before this cosmic light, before atoms existed, gravitational waves were born. Faint, ghostly ripples in space-time itself, generated during the earliest instance of inflation. They would have traveled unimpeded through the newborn universe, their echoes imprinted subtly on the polarization of the CMB. Detecting these primordial waves would be like hearing the universe inhale, for the first time, listening to the vibration of space-time as it came alive. Experiments such as BICEP, Planck, and the upcoming Lightbird mission now search for this signature, a delicate swirl in the cosmic background, a fingerprint of the first gravitational tremor. If found, it would confirm that even the universe's silence began with music at the heart of this. Narrative lies a meeting between two great visions of reality, Einstein's and the quantum worlds. Einstein's general relativity paints space-time as a smooth, continuous fabric, bending under the weight of matter and energy. Quantum field theory, on the other hand, reveals a world of discrete vibrations, fields and probabilities that shimmer beneath all form. For decades, these two visions have stood apart, elegant, powerful, yet incomplete without the other. But in the first instant of creation, they were not separate. The geometry of Einstein's space-time and the fluctuations of quantum fields were intertwined, shaping the same phenomenon: expansion as music, motion as being. Here, space did not merely stretch, it resonated. It learned to oscillate, to pulse, to breathe, and from that breath emerged gravity, time, and light, not as separate entities, but as harmonics of the same song. This harmony can be glimpsed in the mathematics of inflation. A scalar field, known as the inflaton, may have driven the expansion, its energy density nearly constant, like the sustained note of an organ that fills the cathedral of space. As it decayed, the field released energy into particles, giving rise to the hot, dense universe that would later cool into stars and life. If true, it means the universe began as a field vibrating in equilibrium, a pure tone that swelled into a chorus of matter and radiation. And even now, long after that first breath, its rhythm persists. The universe continues to expand, its tempo set by the same forces that first stirred it. Some cosmologists believe the mysterious dark energy driving today's acceleration could be the lingering resonance of that ancient field at the aftertone of the universe's first inhalation. If so, the cosmos has never truly stopped breathing, it merely shifted key. To stand beneath the night sky is to witness that breath made visible. The light from distant galaxies is stretched by expansion, its wavelengths lengthened into red. Each photon that reaches us is a message from the past, stretched, softened, aged by the rhythm of cosmic breathing. What we call the redshift of galaxies is not motion through space, but the stretching of space. It is space-time itself exhaling. Every star, every cluster drifts apart not through travel, but through participation in this universal breath. And though it may seem that galaxies are racing away, they are, in truth, held within the same rhythm, as if the entire cosmos were a single organism expanding, contracting, and evolving in slow, majestic respiration. For some theorists, this pattern hints at something even deeper, that the Big Bang was not the beginning, but a phase transition in a larger, eternal process. Perhaps the universe breathes in cycles, expansion and collapse, inhalation and exhalation, each epoch giving rise to new geometry, new laws, new songs. Theorists in quantum cosmology, such as Roger Penrose and others, have proposed that our Big Bang may have been the quiet exhalation of a previous cosmos, its ashes stretched into our own creation. In such models, entropy never ends. It transforms, diffuses, and resets. Each cycle, each breath, leaves behind faint traces in the fabric of space-time. The memory of a cathedral that once sang, now silent, yet never truly gone. And so the metaphor becomes more than poetry. The universe, in its first trembling moment, was not built like a structure of stone. It swelled like sound. Its architecture is rhythm, its foundation vibration. Einstein's equations describe the structure, the shape and curvature of the cathedral. Quantum fields describe the breath, the living energy that fills and animates it. Together, they form a single vision, a universe that is both architecture and music, both cathedral and song. In that union lies one of the deepest truths modern physics has yet revealed, that existence is not merely a collection of things, but a process, a continual unfolding. And in that unfolding, every particle, every galaxy, every thought participates in the same ancient rhythm that began more than 13 billion years ago. Today, scientists trace that rhythm with satellites and detectors, measuring faint microwaves, tiny distortions, gravitational whispers. Each signal is a clue, a fragment of the original score. We are learning to reconstruct the universe's first breath, to translate geometry into music, numbers into resonance, physics into poetry. The task is immense, yet it carries a quiet humility, to listen to what was once thought impossible to hear, the breathing of space-time itself. For perhaps that is the real discovery, that we are not separate from the symphony, not mere listeners but expressions of the same resonance. Our atoms were once part of that first expansion, our being born from its pulse. Every inhale, every heartbeat, every oscillation of thought is an echo of that first cosmic breath. The film slows. The music falls to a single sustained tone. The narration softens to a whisper. When the universe learned to breathe, it did not create life. It became it. Each rhythm since, from the orbit of moons to the flicker of neurons, is a reflection of that first expansion, a memory still unfolding. The silent cathedrals of space-time continue to resonate, their invisible walls expanding, their geometry alive with ancient music. And somewhere, buried deep in that stillness, the first breath continues, slow, steady, eternal, reminding all who listen that creation was never a single event, but a song still being sung. In the grand vault of the cosmos, there exists a silence so profound that it defies all human sense. A silence not of absence, but of presence. A hidden structure upon which the visible universe is built for decades. Astronomers gazing into deep space have witnessed motions that could not be explained by what their telescopes revealed. Galaxies spinning too fast to hold themselves together. clusters bound by invisible hands, light bending around nothing at all. Something unseen was shaping the cosmos, something vast, weightless, and unyielding. This mystery came to be called dark matter, a phrase that conceals more than it explains. It is not darkness in the way night is dark. It is dark because it does not speak to light. It neither glows, nor reflects, nor absorbs. It passes through the luminous world like a ghost through glass. And yet, by its gravitational pull, it draws the visible universe into form. Galaxies are not scattered at random. They are woven into filaments and clusters, stretched across the cosmic web, each filament a vast bridge of unseen mass, each galaxy a mere dusting of luminous paint upon an invisible frame. In the quiet equations of the 20th century, a paradox had begun to whisper. When Fritz Zwicky studied the Coma cluster in the 1930s, he found that its galaxies moved as if gripped by a hidden mass hundreds of times larger than what could be seen later. Vera Rubin traced the rotation curves of spiral galaxies and found a similar disquiet. Stars at the outer edges spun far faster than gravity should allow. They should have been flung into the void, but they stayed, bound by something unseen, something that must outweigh all visible stars combined. So began the search for the invisible scaffold of existence. Physicists imagined a hidden population of particles, weakly interacting, yet massive enough to shape galaxies' WIMPs. They called them weakly interacting massive particles. Elegant, silent, and nearly undetectable billions may pass through every human body each second, never touching, never leaving a trace detectors buried beneath mountains. In Italy's Gran Sasso, in Canada's Snow Lab, in the depths of South Dakota's Sanford mine, wait for the faintest whisper of a collision. A single flash of light that might reveal the ghostly substance holding the Milky Way together. And yet, despite decades of waiting, the silence endures. Some theorists have turned to lighter ghosts, axions, hypothetical particles born from quantum symmetries. They could fill the cosmos like a silent fog, twisting magnetic fields, humming faintly at radio frequencies that experiments like ADMX in Washington now strain to hear if discovered. They could explain why the universe resists chaos, why the equations remain balanced in their quiet perfection. But perhaps dark matter is not made of particles at all, perhaps. It is a property of space-time itself, a subtle curvature misread as mass. Some propose that gravity behaves differently. On cosmic scales, that what we call dark matter might be the echo of an incomplete understanding of how space-time bends every hypothesis, adds a new arch to the cathedral of thought, yet none completed. The scaffolding remains unseen, though the structure it upholds is everywhere. Beyond even this mystery lies a greater silence still, the force that stretches the universe apart. When Edwin Hubble first saw that distant galaxies were receding, it seemed the cosmos was expanding, but in 1998, observations of distant supernovae revealed something stranger. The expansion was not slowing, it was accelerating. A hidden pressure, a repulsive energy, was pushing the fabric of space apart. It was not matter, dark or otherwise, it was something deeper, something woven into the vacuum itself. Physicists named it dark energy, a placeholder for an idea that resists comprehension. It may be the energy of the vacuum, the restless zero-point field whose faint trembling drives the cosmic expansion, or it could be something dynamic, a new field permeating space, evolving slowly as the universe ages. This field has been given a name drawn from the language of philosophy: quintessence, the fifth essence beyond earth, air, fire, and water, a substance that does not gather, but disperses a silent wind that breathes through the stars. And yet, dark energy is not chaos. It is the quiet expansion of the possible, an architecture of absence that allows everything to drift apart without shattering in. The present cosmological model, the LCDM universe, roughly 68% of the cosmos is made of dark energy, 27% is dark matter. Only about 5% is the matter of stars, planets, and people. Everything that can be seen or touched is a faint embroidery upon a vast invisible cloth in this light. The cosmos begins to look less like a machine and more like a cathedral, an edifice whose foundations are not built from stone or light, but from silence itself. Dark matter forms the pillars. Massive, unseen and enduring dark energy becomes the arches. Lifting the ceiling ever higher between them, the luminous galaxies sing their quiet hymns of creation. Suspended in the dark, the Milky Way, like every spiral, spins in perfect balance within its invisible halo. The sun moves through this unseen sea at hundreds of kilometers per second, its orbit cradled by a substance that no eye has ever seen. Every star, every planet, every atom, drifting in a gravity not their own, simulations of the early universe, such as those from the Illustris and Millennium projects, reveal this hidden geometry, filaments of dark matter threading across billions of light years, forming the skeleton of the cosmic web. At their intersections, galaxies ignite within the vast voids between. Light grows thin. The universe's true architecture is not made of what shines, but of what remains unseen. And yet, to understand this darkness is to confront a deeper question. Why does anything exist at all? If most of reality is invisible, then what is visibility itself but an accident, a surface shimmer upon the deep ocean of the unknown zone? Physicists suggest that dark energy may one day unmake the very structures it once helped build. As expansion accelerates, galaxies will drift beyond each other's sight. The night sky will grow empty. Even the whisper of the cosmic microwave background will fade. A silent cathedral with no congregation. Only the architecture remaining. Others imagine a gentler fate. That the acceleration will slow, that dark energy may decay, giving rise to new structures, new cycles of creation that the universe, like breath, may one day exhale, then draw in again. In the end, all theories circle back to a single idea, that darkness is not emptiness, but structure. Not silence, but resonance beyond hearing. The cosmos is not a void sprinkled with light. It is an invisible masterpiece, sculpted by forces that will never be seen, yet always felt. The dark architecture of the universe is not a failure of perception. It is a reminder of humility, that the human eye was never meant to see everything, that the true design of existence lies beyond the visible spectrum, beyond even comprehension, and that within this vast unseeable expanse, the visible world, stars, oceans, life, becomes a fragile illumination, a candle flickering within the cathedral of night. As the universe expands, it carries that candle forward. Each moment a new arch built across the dark, each discovery a quiet echo of the first act of creation. And through it all, dark matter and dark energy, the invisible continues its patient work, holding galaxies in orbit, stretching space toward infinity. It is the unseen hand that sculpts the cosmos, the breath that moves without sound, the silent architecture that holds everything we have ever known. There comes a moment in every great story when the light reveals not perfection, but fracture. When the architecture once thought divine begins to tremble under its own design. The universe, for all its vast coherence, hides beneath its surface a tension so deep that even the laws of nature no longer agree. For a century, physics has spoken in two tongues. One, the language of Einstein, smooth, continuous, geometrical, a world of space-time curvature and gravity's graceful arcs. The other, the language of the quantum, restless, probabilistic, defined by uncertainty and chance. Each describes a truth so compelling that neither can be denied, yet where they meet, both dissolve into contradiction. Einstein's general relativity describes the universe as a grand fabric mass and energy bend. Its planets, stars, and light follow the curves it creates. It is a theory of scale and simplicity, from the orbit of the moon to the lensing of galaxies, and in every test, it has held quantum mechanics by contrast. Lives in the small it rules the behavior of atoms, of particles, of the very quanta that make up light itself. It speaks of probabilities instead of certainties. Particles that are waves, waves that are particles, a realm where observation changes the thing observed. Each theory is exquisite within its own domain, but together they cannot coexist when quantum rules are applied to Einstein's smooth geometry. The equations implode. Curvature becomes infinite, energy densities rise without limit. The mathematics breaks, like stained glass shattering under its own brilliance. This fracture is most violent where nature itself reaches its extremes. Inside the heart of a black hole, where gravity crushes matter into a singularity, and at the first instant of creation, when the universe expanded from an infinitely dense point at these edges, space-time ceases to be a continuum. It becomes something else, undefined, unknowable. Physicists stand here like artisans before a cracked altar, two great temples of understanding rising beside one another, neither false, yet neither whole. The cathedral of physics is split along its foundation, so began a new era of searching. A quest not for new phenomena, but for a new language. Some turn to string theory, a radical attempt to weave both quantum mechanics and relativity into a single fabric. In this vision, the smallest entities are not particles, but vibrating strings, infinitesimal filaments of energy, oscillating in multiple dimensions. Each vibration corresponds to a different particle. Photon, electron, graviton, matter, and force become harmonics of the same underlying melody here. Gravity emerges naturally. The graviton, the hypothetical quantum of gravity, is one of the string's lowest notes. In this model, space-time itself is not fundamental. It is the resonance pattern of these tiny vibrating loops, a symphony rather than a stage. But the cost of this beauty is complexity. String theory requires extra dimensions, 6 or 7 curled up beyond perception, mathematical landscapes of possible universes, numbering more than the atoms in existence, a multiverse of equations, each self-consistent, yet none proven real in laboratories and accelerators. No string has yet sung. Its vibrations remain purely mathematical, a music heard only in theory. Others turn to loop quantum gravity, a different attempt to reconcile the two great faiths. Here, space-time is quantized, not smooth, but woven from loops of finite size, the smallest possible grains of volume and area. Just as light comes in quanta, so too does space itself. This framework suggests that the singularities of black holes and the Big Bang are illusions, that space cannot collapse below its fundamental unit, that there is no infinite density, no true beginning, only a bounce, an oscillation between creation and collapse. But even loop quantum gravity, for all its elegance, remains incomplete. It explains the geometry of space, but not the matter that inhabits it. It reveals structure, but not the song that fills the structure with motion. Between these two attempts, the vibrating string and the quantized loop, a third idea emerged. The holographic principle in the 1990s. Physicist Gerard 't Hooft and later Leonard Susskind proposed a vision both simple and astonishing, that everything we perceive in 3 dimensions might be a projection of information encoded on a distant 2-dimensional surface, like a hologram. The depth of reality could be an illusion, a mathematical projection from the universe's boundary. This radical idea found strength in the study of black holes. When Stephen Hawking discovered that black holes emit faint radiation, a paradox was born. If black holes evaporate over time, what happens to the information they contain? Quantum mechanics forbids the destruction of information. It must be preserved, even as matter falls beyond the event horizon. The holographic principle resolves this tension. Information is not lost inside the black hole. It is stored on its surface, a cosmic ledger keeping perfect account of what once fell in. In this way, the universe itself might operate as a grand hologram. Everything that occurs within its volume written upon its cosmic boundary. 1997, physicist Juan Maldacena formalized this insight into a profound correspondence, known today as the ADS-CFT duality, a bridge between quantum theory and gravity, a statement that a theory without gravity on a flat boundary can describe a theory with gravity inside a curved space. It was the first glimpse of a mathematical reconciliation between Einstein's geometry and the quantum realm. For the first time, 2 halves of the broken altar seem to reflect one another. Yet, as with all deep revelations, certainty did not return. It fractured further into new questions, new paradoxes. If space-time and gravity can emerge from information, then what is information itself? If the universe is a hologram, What is the surface upon which it is written? And who or what is reading the pattern? In recent years, physicists have turned toward quantum information theory to probe these questions. They now speak of entanglement, the strange linkage between quantum particles, separated by vast distances, as the possible source of space-time itself. In this view, space may not exist independently. It may arise from networks of entanglement, from the relationships between particles, rather than the particles themselves. Space-time is a tapestry woven not from threads of matter, but from the connections that define them. If this is true, then reality itself is relational. A web of quantum interactions giving birth to geometry, gravity, and motion. The cathedral metaphor deepens here. The visible pillars, stars, galaxies, atoms, are merely the upper walls. Beneath them lies an invisible foundation, a vast interconnection of information, vibrating strings, quantum loops, and entangled relationships. The altar is cracked, but from its fracture, a more intricate design begins to emerge in laboratories across the world. From CERN's Large Hadron Collider to Fermilab's quantum gravity group, fragments of this future theory are being forged. Tiny disturbances in quantum fields, correlations between gravitational waves and cosmic inflation, mathematical whispers that suggest a coming unity, though distant, faint, and incomplete. The paradox of modern physics remains. Every success deepens the mystery. Every answer fractures into more subtle questions. The closer scientists draw to the origin of space-time, the less space-time itself seems to be the true foundation. It is as if the cathedral of physics has grown, so vast that its architects can no longer see its ceiling. Each archway reveals another hidden corridor, each equation another chamber filled with echoes at the heart of it all. One question endures. If reality is built upon uncertainty, what then is certainty itself? If the laws of physics can break, what remains unbroken? The story of science has always been one of symmetry and shattering, of elegant ideas that fracture under their own beauty, only to be reformed into deeper truths. Today's theories, relativity, quantum mechanics, string, loop, holography, may be but scaffolds, awaiting the next construction, a unified framework not yet born, one that will mend the cracked altar and reveal what truly lies beneath the fabric of being. Until then, the universe remains suspended between equations, balanced between two incompatible visions of reality. A place where gravity curves the infinite and probability breathes through the void in. That tension, in that exquisite and irreconcilable paradox, lies the truest reflection of the cosmos. A structure both broken and whole, both music and silence. A cathedral still under construction, built upon uncertainty itself. There is a moment in every scientific age when silence becomes its own form of revelation, when equations lose their certainty and reality. Once thought solid and continuous begins to shimmer like heat. Over a desert horizon, that silence has arrived. Again, across the black halls of theoretical physics, the universe is no longer drawn as a field of infinite coordinates, but as a woven network. A map of silent cities strung together by the delicate threads of information. Every star, every particle, every event in cosmic history, not a point in space, but a node in a grand lattice, a hidden web where meaning replaces matter. The story begins with mathematics, the language that once sculpted space-time into curves and continuums. But under the scrutiny of quantum mechanics, that smooth geometry began to crack. Einstein's fabric of space-time, once thought continuous and unbreakable, trembles beneath Planck's scale, the smallest unit where time and distance can still be spoken of beyond it. Meaning evaporates there in that infinitesimal abyss. The universe forgets what it means to be continuous, and so physicists began to rebuild reality from something else, in laboratories lit by computer screens rather than candlelight. Simulations now unfold like dreams inside machines. Theorists at MIT, Caltech, and Perimeter Institute model space-time not as geometry, but as code. They speak of quantum networks, where every link between 2 points of entanglement gives rise to what we perceive as distance. The closer two particles are entangled, the closer they are in the emergent fabric of space-time. Space itself, they argue, might not be fundamental at all, but a mirage rising from deeper informational relationships. Imagine then That the universe is not a stage but a conversation, not built of atoms and void but of messages exchanged, quiet, timeless, instantaneous. Every photon, every fluctuation of energy, a whisper in a grand dialogue that stretches from the birth of time to its hypothetical end. This is where the idea of the holographic universe re-emerges. Ancient and newly sharpened in the 1990s, the physicist Gerard 't Hooft suggested something radical, that all the information contained within a volume of space could be described by data imprinted on its surface. It was Leonard Susskind who transformed that speculation into a framework, the holographic principle, revealing that our three-dimensional reality may in fact be a projection of two-dimensional information encoded on a distant boundary. In this vision, space-time is no longer a canvas. It is the illusion of depth painted upon the walls of a cosmic theater. The black hole became the first great test of this idea. Its event horizon, once feared as the edge of physical meaning, now reimagined as a vast information storage device, each bit of its entropy a pixel. In the cosmic code, if true, the universe itself might be a hologram, not less real, but real in a different language. One where reality and data are indistinguishable. At the heart of this vision lies quantum entanglement. Two particles born in the same quantum state can remain connected even when separated by galaxies. Their properties instantaneously mirrored. It was once called spooky action at a distance. Now it may be the scaffolding of existence itself. Juan Maldaceno's ADS-CFT correspondence, a bridge between gravity and quantum theory, brought this idea to life. It suggested that the warping of space-time, the bending we call gravity, may be nothing more than the collective expression of entangled quantum bits at a deeper level. In a sense, space-time is woven. Each thread of entanglement, a strand in the tapestry. Remove enough of those threads, and space itself begins to tear. Recent experiments hint at this structure. At Fermilab, at Stanford's SLAC, and in quantum computing labs across the world, scientists simulate miniature toy universes, networks of qubits arranged in lattices. Watching as entanglement patterns form emergent geometries that mimic the equations of general relativity, in these models, space-time grows from information like frost blooming on glass, a digital cathedral, rising one connection at a time, and somewhere inside that frozen lattice, a strange realization begins to take shape. That reality, at its most fundamental level, might be discrete, like the pixels of an image, like the notes in a song. If space is quantized, if time advances in indivisible steps, then the universe itself becomes countable. A cosmic computation unfolding since the Big Bang. Physicist Seth Lloyd once called it the universe as a quantum computer, where every particle interaction, every quantum event, represents a single calculation, the total number of such operations since the dawn of time. 10 around 120, a number almost too vast to imagine, and yet, still finite. In that sense, existence itself is not infinite. It is complete, a simulation, not in the technological sense, but in the mathematical one, where physics is the syntax and consciousness perhaps, the grammar that reads it. But every lattice casts a shadow. If reality is digital, what lies between its pixels? If space emerges from entanglement, what gives rise to entanglement itself? This is where physics turns to philosophy once more, and where the boundary between science and mysticism blurs. Perhaps information is not just a measure of order, but the fundamental substrate of being. Perhaps the bit, as John Wheeler once proposed, is the seed of all. It's Wheeler's phrase, it from bit, once sounded poetic, now it may be literal. Every particle, every law, every constant, a crystallization of information from an underlying ocean of potential. If so, then the cosmos is not merely a map, it is a memory, a vast, self-updating record of everything that has ever interacted with everything else in this map of silent cities, these invisible nodes of causality. There is no emptiness, only connections too subtle to perceive. Every black hole, every nebula, every electron field, part of the same unbroken computation. We, too, are part of it. Not observers standing outside the system, but processes within it. Local eddies in an informational sea. And so, the question emerges, if space-time is emergent, what is it emerging from? Some say it is the pure mathematics of Hilbert space, an infinite landscape of quantum probabilities, collapsing into form through observation. Others speak of quantum gravity, a still unknown theory that would unite the discrete and the continuous. But a few begin to imagine something deeper still, that what gives rise to spacetime is not physics at all, but relationship. In the language of network theory, what exists are not the points, but the links. Reality is not made of things, but of relations, each connection defining the others, each pattern giving birth to geometry, to time, to consciousness itself. It is as if the universe were not built, but remembered. And here, at the edge of modern cosmology, lies an extraordinary thought that perhaps there is no fundamental stuff of the universe, no smallest particle, no ultimate layer of matter, only information, structured by laws, interpreted by perception, that everything, from the pulse of a quasar to the beating of a human heart, is a pattern in motion, an echo of the same source. The ancients once built temples to mirror the heavens. Now, physicists build simulations to mirror the void in both. The intention is the same, to touch the invisible architecture behind appearance. In this final image, the universe stands revealed not as a solid cathedral of matter, but as a living, breathing web of connection, a map of silent cities, each one humming with the music of causality, from the quantum foam beneath reality's skin to the galaxies that bloom like lanterns in an infinite dark. Every structure, every symmetry, every law is part of one vast, self-weaving design. And yet, even as science edges closer to this ultimate picture, it discovers something humbling: that the map itself may be infinite in resolution, that no final equation, no simulation, no lattice can contain the full essence of what is, because the universe, in its quiet brilliance, may not just compute, it may dream a dream of geometry, unfolding through time, a dream of consciousness, aware of its own reflection, a dream that calls itself reality. In the end, the quest for the map of silent cities is not a search for where we are, but for what we are made of, and the answer may not lie in matter or energy, but in the stillness between them, in that unbroken silence where all equations fade and the cosmos whispers in the language of information, the single word that gives rise to all others: exist.